Alright, hopefully I can finish some of this today. Okay, let's work out the height of this thing, which should be pretty simple. I mean, we only have one rectangle here, really. So that would be the amount of pairs, the amount of these backpacks times the height of each one, right? Which is just that. Except we want to know how many rows we've got, which is it's not obvious. It's not obvious how many rows we have right away. And we kind of do want to know what the height is of this thing in order for it to scroll correctly. But the width of each rect is... the width of each rect is the string length. Well, plus this padding. Okay, so total height is something we don't actually know what it is. So we in order to work out total height, it would be like total width. Well, not total width. Total backpack width divided by well, if the width is like 3,000, then we can fit 2,000. Let's say. Which is the width of the current rectangle over. Is there a way to? Is there a way to? I think there is, like mu get. Oh, there is clip rect, of course. Get ID, get current. Well. Yeah, we can get current container, which, well, that returns a Can we, well, I think there is a way to get hello chatter. I think there is a way to get micro UI, get up, let's see. Yeah, usage, doc usage. Yeah, so layout. Width. So you can call layout next to advance the system. But can I kind of just want to know how wide the current container is, which we can get a current container. Here, which does have a rectangle, although it has a rect and a body. Maybe that's what we need. Total container width. Oh, like container width. Floored. So that would be like 3000 divided by plus 1. Like it's total backpack rows. That's what that is. And then total backpack height would be total backpack rows times. I mean, I'm calling it backpack here. It's called compartment. Okay, I'm guessing total height is something we don't have. Yeah, many of these things is something we don't have. Okay. Alright. Let's say 99. To see how this goes. What? Unidentified identifier padding. Yeah, so that's just called it something else. That. Okay, so this should result in us having a scroll bar, because we think we have 99 rows of these things. So if we could just work out accurately how many rows we have in advance, that'd be pretty good. So what's the total compartment width? Mu get current container. Okay. Rect width. So presumably it's just that. But let's see. So total bounds. We already have total bounds. Width is 2290. And this is 2312. That's not quite right, because we have a scroll bar, right? Interesting. Yeah. Sometimes it's not that easy to work out how many rectangles you can fit. I mean, I guess we can do this layout, so that's not gonna work. But what we can do is we can lay out a row. Can we lay out a zero length row? Let's see, does this mess us up? So if I lay out a row that's like I mean, it's -1. It's not really what it's supposed to be. Well, let's see. Let's just see what I will. 0 hydro. Okay, well, it doesn't affect much. Probably because we are not calling that. What are these bounds test? Let's see. And how do they compare to total bounds? Well, total bounds lower. The width is the same. The height here is different. Oh, they actually lower by... Huh. I mean, okay, it's kind of hacky, but let's just do 1 pixel. Yeah, there's so there's some kind of padding going on between them. The X position is the same, the width is the same. I mean, I only really want. Actually, what if I mu layout set next? Context rectangle relative. Not relative. Does this do much? No, it doesn't look like it. So 1951. I don't know. This is pretty bad, actually. Yeah, we don't want to do that. Okay, maybe not get current container. Well, there's also get container by name. Okay, which of these returns a rect? Let's see. There's, well, you can create one. You can get a clip rect, which is not really what I want. There's layout next which returns a rect. Yeah, and that's it. So mu layout next really is what we kind of need. But I want to know the width of the thing. Although the width of the thing probably will depend on whether or not there is a scroll bar. And whether or not there is a... And where to draw the scroll bar. We kind of need to lay things out before we know if we need to draw the scroll bar. I mean, what happens, right? What happens if I set this to 0? Okay, well, it is drawn. Yeah, we probably want to take this out. Alt Enter toggle. That's probably what we want. Okay, so if we make it smaller, yeah, it doesn't fit. There is no scroll bar. Okay. And what if, so we do this. And then you do mu layout, what is it, set height or something? New layout height, context height. No, you can't really do it after. Well, how can you? Actually, what is going on there? Seems to be like it just seems to be fixed now. Why is it fixed? That's completely, just completely fixed. Yeah, this is not great. Didn't really expect it to be fixed like that. It's weird. Just we're only drawing within this, and that's it. Although clearly when you create a bigger window, it draws within the whole window. So it does respond to size. It's just not to this, just not to the resize. Yeah, here, I'm creating a window with window height. Yeah. So if I make it smaller and set a breakpoint here, 975, 1020. Well, okay, this is definitely super small. Width is 120, yeah, this is 1020. And yet, well, like right now, what's the width and height? By 2560 by 1417. Yeah, that sounds about right. Wait, is it because this is like a window that's not resizing? Yeah, it's a window and it's not resizing because you're supposed to like resize it manually. And even though I'm telling it to create a window that's larger than that, it's ignoring it because it's like retained the previous state of the window. Yeah, this is just so annoying. So annoying. Well, so there's this problem, and there is also the problem that I can't lay things out in advance very well. And I can do it manually. Okay, so what is going on here? None of this. Yeah, I'm just gonna discard all of that probably. All I did is did that. Okay. Okay. It's like, let's see how many. Oh, no. How many rows do we got? Okay, rows is 27. Okay, so like really the height should be 27. That's the problem is working out the 27 is actually kind of difficult. Work out 27. Don't need rows. Yeah, that's only one of the problems with UI. But at least we don't have at least we don't have the scroll bar now. That's something. Like if we create a smaller window, then we'll probably see a scroll bar. Yeah, well, this is way too small. And it's not gonna get any bigger because this is a window that we can't force to make to like become bigger. Or can we force it? Like the whole thing begins here. No, actually, begin window. Yeah, I didn't call anything that. I mean, like I don't want it to reuse the window. I wanted to actually create. So this is the problem with these fucking immediate mode UI libraries. They're not actually immediate mode. Like, I'm telling it to create a window with one width, it creates a window with a different width. So you have to like change the ID every time. I mean, I guess you can set push ID, data size, pop ID. Get ID for data and size. So I'm guessing if we do something like string builder scratch font. If you put them all, like paste them all together, paste them in alternate. Vanity resize, yeah. Because now it's a different window. I mean, it resizes jankily, but it resizes. This is to force the window to resize. Do we have temp memory? Yeah. Okay. Not a fan of that. Fine. Now, this other problem. What if I call mu layout next, like right here? Happens then. Well, I don't need a window to be this small now. What if I... Oh well, actually, it didn't mess anything up too much. And this temp rect. Okay, so its width has nothing to do with anything. Yeah, I mean, I guess you kind of have to do something like that. And now these two rects have the same width, so you can kind of use it. Let's just follow through with this and see where it leads us. And I guess this is all like layout, bounds. So we know the bounds now for each backpack. So backpacks. For each of these things, width would be backpack 1 length times frontage width plus padding. Int total width 0. So that's the total width. Now we have also the bounds width. Int rows is total width divided by bounds. Okay, well, I guess this is where it's leading us. What's the rows? 18. Interesting. Total width, bounds width. Well, we know it's not 18. Although, in this case, it might be 18. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 full ones plus 1. I mean, it's janky, but it does kind of int rows. Well, I mean, like it's that, right? Okay, it's not great. This is not great. But I guess this is just what has to happen. I guess it just has to happen. Okay, can we toggle this? Put this on a toggle. Oh, well, do we have anything else here? No. Void toggle full screen. Okay, so full screen does that. Well, toggle full screen. Right now it just sets full screen. Ideally it would toggle full screen. this shouldn't do anything different. Yeah. Okay, now well, okay, so let's see. So there's only one code path here. Normally there's two. Yeah, so this is what we are doing, setting the full screen. And this is, well, I mean, actually you can just kind of know. If yeah, else, there we go. So if, then set and set, else do these three sets. Oh my god. We do need to store previous placement. And we get window placement. Okay, so this GW that's just window placement. Okay, so every time we toggle, we get window placement. No, that doesn't make sense. Yeah, it doesn't. It's more so like this. And monitor info, we only really need that. Here. Okay, so we get the style. If the style says that we are not full screen, then we do this whole window placement thing. So this is just to save it. Then we get monitor info. If the style tells us we are full screen, then we set window placement and set position to that, which apparently makes it work. Okay, well, first of all, does the so that works. I'm not binding it to anything. Okay, so let's just toggle full screen right here. And then where are we reading input? Here. Well, case WM sys key down. I mean, I think this one switch message wparam case vk return default break. is that gonna... No. No, there it is. Does this work? Yeah. So just pressing enter doesn't... This does. Alright. Okay, now I can't Alt F4. Is Siski down already here somewhere? No. No, because I'm intercepting it, that's right. So now I actually have to case VK F4, we just break main loop. Okay, so just F4 doesn't do it, but Alt F4 does. And I think it's just the Alt. It's like Shift F4 isn't gonna do it. Space Control. Yeah, it's just Alt. All right. How's the output? It seems fine. Okay, well, there's our full screen toggling. Okay, so this annoying feature of MicroUI, where it doesn't adjust quite like here. I mean, the jankiest solution is to just do poll message. And just kind of mask it with fast updates. Well, that's post message. I want peak message. And does it return? If there is a message, then non-zero. If no message is available, return value is 0. Was I using get message A? Yeah. Peak message A. Okay, well, what are we taking? Message window filter and remove. Filter PM remove. PM remove. So while I mean, really, it's a for loop. For message, big message. What are we doing in here? Quit, buttons, key down, syskey down, default. Yeah, I mean, this seems fine. Okay, now we have polling messages, and yeah, we still have that janky update, but we kind of can't see it because it's fast. Resizing, well, this is the smoothest it's gonna get. That height isn't worked out correctly. as here. Here it's fine. And here it's also fine. Okay, now I just need to work out the height correctly, and then we'll be good. Let's find out what rows 22. Is that correct? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. No. It's not correct. There's 23 rows. Yeah, all these gaps, right? They add up. So just +1 as I'm doing now isn't enough to account for them, because there's a lot of them. And they're pretty big. So really, I mean, the best way would be, instead of working out total width, is just to work out the rows. Right? Is to basically repeat this thing. Like, int current x is bounds x. Width is that. Current x plus equals width. If current x is greater or equal, let's see, greater, bounds x plus bounds width. I mean, I can even set it to just 0, right? If current x is greater than bounds width, then current x equals 0, and then rows plus equals 1. And just init the rows at 1. And presumably, no, that's still not quite right. So 1 break, 2 break, 3, 2 rows. That's interesting. Why not? "25 rows is what's been calculated. It's the width. Oh, yeah, because when we transition to the new one, current x should actually be width. Yeah, now the width is worked out. Now the height of this thing is worked out correctly. Alt enter seems to be working fine as well. Well, oh yeah, exiting the program seems to not exit the program properly. So let's find out what that's all about. Apparently we don't get the quit message. Even though we used to get it. Like, I'm just creating it with the default proc, right? I'm creating it with the default window proc. Which means that it's not. So the destroy window message comes into the default proc, which apparently doesn't post the quit message or something, like, I don't know. Oh well, it... Does peak message doesn't return anything, right? Yeah, normally normally what happens is you just kind of create an well, let's see. So this default window proc thing is that. Can we just okay, so that would be here. Does that work? Stern windows. Yeah, that works. Does it work, like, just in general? Yeah, it seems to be working fine. If message is WM destroy, I think it's destroy. Post quit message. Like, is that what we need to do? No. Do we even get here? No, we do. But then we just never get quit. Or is it because we're calling def window proc? Yeah, we never get quits seemingly. Else WM destroy. Yeah. Return 0. Okay, let's not call the window proc. So now we remove it, post, but then we never hit the quit. Is peak message just not, like, there's no messages, the window's gone or something? Okay, well, that doesn't help us much. Is there some other message we're getting? Let's look at the reference. Do we have? Yeah, we do. No, it is destroy. If message is quit, then break. Yeah, that's what we're doing. Oh. Of course. Now that quits it. That also quits it, although not through there. Yeah, no. Okay. And is it because of this? What if I don't do it? Like, what if this whole thing doesn't happen? Alt F4, now that exits. That doesn't. No. I see. Alt F4 exits, but pressing the close also exits. Okay. Amazing. Okay, do we have any to-dos? We don't have any to-dos. Alright, let's just see quickly that it doesn't like weirdly crash because of being too small or whatever. Yeah, I mean, it doesn't look very good, but at least doesn't crash. Alright, well. Yeah, that's fine. Improve UI behavior. Okay, so the only thing I haven't really done, indeed, that I want to do is probably just SIMD. CD lang SIMD. Vector extensions, yeah. Yeah, best practices. Use the declarations in core SIMD. And you can just use these types. Type like int4. Yeah, well, everything has 4 wide SIMD pretty much, so we can at least use int4 and see how that goes. Well, we have this line range that's scanning, like that's doing this loop over the characters. Do I call it in tests? Tests. Yeah, I do. Call it right here. Yep. Okay, well. So this can be SIMDized. fairly easily, except for the fact that we can't pad it really, so, well, we could pad it. But this is it's like an input string that comes from somewhere, so I don't really want to pad it, just so we can read off the end. So the tail will have to be scalar, but at least we can do most of it 4 wide. Static if, I mean, you can even do just static if is. I mean, in this case we kind of want 4 wide SIMD that's 16. We can fit 16 bytes in there. Right, 256. 128. 128 by 8. Yeah, that is 16, isn't it? I mean, we don't even need SIMD to do this wide, kind of. Well, I mean, it's nice to have those instructions though, because this is a byte. By iterating through the string, byte by byte. All right, let's do that. Let's do that then. Okay, so this is what we've got. Yeah. I mean, I'm guessing it's not gonna be. Yeah, this is 128 bits. Yeah, we're just gonna stick to that. Byte 16. Byte 16. Is that something I can just do? No. Well, import core SIMD. Okay, now we have byte 16. Oh my god. Yeah, okay. Instead of iterating sort of 1 character at a time, we can iterate essentially 16 characters at a time. While unprocessed length is greater than 16, right, it's at least 16 bytes, then we can do a SIMD loop. Otherwise, we can't really. Line and search. What's this label not used? Well, we're gonna use it. Where is unprocessed updated? Yeah, this is probably not how we want to do that actually. Yeah, because the offset is updated. Because what we're storing actually is the line. So this is our string. If the string is less than 16 bytes, don't do scalar. I mean, well, do scalar because we can't assume that we have masked reads. So all of this stays. If the string is at least 16 bytes, then we can do SIMD. Except that we kinda need to check every time. So size is how deep into, okay, so first of all, for int equals 0, int is less than unprocessed length. I mean, I guess it's like long. Int plus plus, and then char is unprocessed int. Okay, that's the first thing. So that's the scalar loop. And the SIMD loop would be, we're just gonna step by 16. Yeah, int is less than unprocessed length, but it's specifically because we're going to be reading a whole chunk. We need to know that int plus 16 is less than unprocessed length. So if the length is exactly 16, then int to start with is 0, int plus 16, okay, so less than or equal to. Okay, so this means that we can read the whole 16-byte chunk. And on the next iteration, int will become 16. So int plus 16 will be not less than the length. So this will break. This will not, we will not go into this loop at all. And then, well, need to update the size here, okay. So like right here, actually right now this loop is not interfering with the other one. Yeah, so we can just write some things here. Do we have SIMD like indexing? Like the first thing we want to do is actually read that memory. Like how do I do a load? Do I just not like where? Core SIMD for supported intrinsics, okay, well, I want load. Load unaligned, yeah, that sounds pretty good. Constraints, wow, look at that. Load unaligned. I see, so byte 16 ch16 equals load unaligned from unprocessed putter. Well, I mean it's unprocessed putter plus int, right? Oh boy. None of the overloads are callable. Candidate is must satisfy constraints. Well, cast byte star do I need to cast it as a byte 16 pointer? Okay, sure, why not? Let's examine that. Let's see how SIMD debugging goes. Oh boy, signed char 16. Well, that's at least not that bad. What's unprocessed? Okay, well that actually seems like what we want. Yes. Okay, so now I want to do a parallel compare. Equals, right? Load unaligned, store unaligned, prefetch. Okay, that is not a lot, I must say. I mean, I guess, like, what happens, like, hold on. Can I instantiate? Okay, what happens here? Let's see. Byte 16, line feed 16 is that. Like, what's this gonna be exactly? Actually, that is a broadcast. Yeah, that's good. Okay, so this right here is there's our well, there's a bunch of movs here, but then we have this mov dq. Yeah, we need to do some pointer arithmetic first, and then we can do a mov. And the second one is let's see. Oh my god. Okay, the second one is just a mov dq. Double q from whatever, some constant thing. Alright. I mean, that's fine. Well, now we need to do a compare, which will get us a mask, which is like a U short, I guess. Comp mask is ch16 equals lf16. Something like this, right? Well, this instruction doesn't return byte 16. Okay, whatever. Byte 16 comp result. I mean, that returns a mask typically, but I mean, okay, fine. Vcomp, yeah. Okay, what's comp result? I mean, the fact that this is a byte 16 and not a mask is a little strange. I mean, that is the instruction that does it. compare back data for equal. Corresponding data element in the destination operand is set to all ones. So no, the instruction actually doesn't return a mask. I mean, fair enough. Now that's just moving things to the stack or something. Yeah, base pointer, yeah, seems like it. So -1, yeah, that's all ones. So the fourth one, well, that one is -1, so okay. Is there... fx. Let's see, Intel intrinsics. MM128. Is it M128? It is MM128. Compare EPI 8. Okay, all of these are apparently AVX512. Maybe without the compare. Oh, maybe compare is the wrong one. Equals EPI 8. Yeah, so that's SSE. Compic. EPI 8. P comp ic b. This is V p comp ic b. Still the results in dest. Yeah, so this doesn't return. So the masked ones, that's actually AVX512. And this is the instruction that we are seeing. Vcomp vpcomp ic b. Yeah, we're actually seeing this one. Why are we seeing this one? I mean, it's XMM. Is it just the encoding that's wrong? What's going on there? Yeah, it should be this one. And move the results into dest. Flags as a C2. Yeah, no, I mean that does make some sense. Yeah, that's AVX. Huh. I mean, maybe that one also takes XMM registers. Well, anyway, the point is we are getting kind of what we want at this point. Except that we kind of want to know, we want to collapse that. We want to collapse that, ideally to just one number. Well, we don't just want to collapse it though, we want to know which one, if any, is all ones. Okay, can we do that? How do we do that fast? Well, like this instruction, right? Store results in mask using 0 mask K1. Yeah, the masked ones, that's AVX512 exclusive feature. Well, ideally I just kind of want... Like, this is not exactly super useful. All these side chars. Is there anything that returns a mask that isn't AVX512? String compare, well. Now there's special string compare instructions? Apparently so. And they're SSE. Well, we don't really want the string compare though. We want to find the character. Swizzle, set, shift, set, shift. Yeah, we don't really want that. Miscellaneous, mask. Look at that, all of this is AVX512. Logical. Compute bitwise AND. So that returns an int. Okay, so maybe these tests is what we want actually. So let's just look at SSE, MMX, and yeah, let's look at these two. So we specifically want the thing there we go. Test all ones. Apparently that's not an instruction though. Test all zeros on the other hand. That is an instruction, that's ptest. Now that just returns a boolean. Compute bitwise AND. And return 1 if the result is 0. There's also this test mix 10. Compute bitwise AND of 128 bits in A and mask. And set ZF 0 flag to 1, otherwise 0. Compute the bitwise not, and then set CF to 1. Okay, well this is definitely a candidate. General support, fns, empty, prefetch, undefined, math functions, convert. Convert lower and store result. Convert lower and store result. So that looks like that's what these do. They just sort of convert lower. Compare. What's this? No, wait, that Compares lower. Oh, so that's just compares lower. Alright. Compares lower. Cast. Bit manipulation. Nothing. Nothing in these two. Arithmetic. Well, I mean, add applied, whatever. Unknown. Nothing. Okay. Okay, so how do we get the number 4 out of this? 0, 1, 2, 3, 4. I mean, we could just loop and count. And early out if there aren't any. Well, I mean, I guess that's the first part, is check if there are any here, which we can do with test, right? P-test, like test all zeros. Okay, so this is this and mask. Okay. So that would be something like int lf found would be comp result. Well, I mean, we want this p-test. Not vcomp, but p-test. How do I generate a p-test? Do I just not? I mean, sure, we have all these operators, but like, these are wide operators. I want to test all zeros or test all ones. I mean, I guess bitwise AND will maybe generate it. Well, let's find out. And byte 16. I mean, if you end it with all ones, is that? Okay, so see, this will not generate what I want. This will generate a bitwise AND that's 16 wide. No. No, I just want the p-test. I just want that. Just give me that. Do I have to write inline assembly to make that happen? Maybe. Can I use variable names in ASM? Like you just do that, right? So that's not hard. These are registers. Stack variables. Indexed by EBP. Oh, you can use variable names. Now EBP is emitted. You can emit EBP. Okay, well what I want is, let's see what happens here. Well, I want to store the result somewhere, right? Oh man, okay. B-test. B-test sets the 0 flag. Well, let's just try it. B-test. Um, 116. Bad type size of operands p-test. No. No, it isn't bad. Excuse me. I mean, it has to be registers. Yeah, so that's just a bunch of ones. That's fine. And comp result is 16 bytes. So comp result is 16 bytes. 116 is 16 bytes. P-test takes 2 operands. Which 128 bits each. SSC4, yeah. Set the ZF flag. If all bits in the result are 0 of the bitwise AND of the first operand, yeah, there is a 128-bit version. Yeah, the first one is a register, and so I guess you have to set a register first. Which is, let's see, where's our registers? Registers. Can I have more? Yes, so that's just XMM whatever, right? Except that some of the registers are already occupied. Do I have to write the whole thing in assembly? Like, can I not use any of this? Like, just partial assembly just doesn't work. There is our 0 flag, by the way. Carry flag, yeah. Yeah, so we've clearly set some of these registers to something already. And it's not clear that, well, yeah, it's not exactly obvious that if I just set XMM0 to something here, that it won't mess up some of this other stuff that we already have. Man, these intrinsics are a lot easier to use, I must say, than this weird, like, well, how do I generate this instruction? Well, you don't know. There's bunch of wide instructions you can use, but anything other than that. So, I mean, I guess it's really something like if comp result then do something, right? It's like that, but and you see, it's too dumb to generate test here. The compiler is too dumb. Okay, so SIMD support so far not impressive. Not impressive. Well, I guess it will be something like this. So we work out what the pointer is, so that's gonna be stored, somewhere. That's not an XMM. And then we just go into assembly. Yeah. And then we just go into assembly. Where's load? Load you. Yeah, there's load unaligned. I mean, SI 128, sure. LDDQ into a register. Well, let's try it. LDDQ. LDDQU. XMM0. What is it? XMM0, like that. And footer. Is there a semicolon? Well, I mean, it's a variable, right? Like, just that's the memory address. Do I have to do this EBX thing? I mean, it's right here. What? Or is it like, is there no semicolon? No, there, wait. Bad type? What bad type are you talking about? It's literally that memory. Okay, LDDQ. Load unaligned integer. Apparently this is SSE3. Load and align data from mem and return double quad words in XMM1. that's just an example, presumably. Why can't I just use pointer here? No, you can. It's just putter is like special. Apparently so. Is mem special? No, bad type size of operands. Is it? Yes, it is semicolons. Subunited. This is worse. Second operand. Pop EBX. Yeah, I mean, I guess you can save the registers. This would be one way of doing it. Do some pushing and popping. Yeah, there's XMMs. Shift or yeah, all the opcodes, well. Okay. Move into APX and then foo offset of APX. What, EBP? Ah, no, there you go. Move into EAX X. Well, can we try just that? I mean, this would be like RAX, I suppose. Does that work? It does. I mean, this will probably mess us up a little bit because RAX might be used. But let's just see what's going on here. Yeah, it literally just moves it. So there's our RAX. Well, right now it's not anything. And it just moves it in there. That's fine. XMM0. Does it need to be like in brackets or something? No. I mean, this like this is the memory address I want you to load this stuff from. Just do it. Hold on. Is it gonna do it if I hide it in the register? I mean, apparently Okay, this is not amazing, but okay, so RAX is set to the correct thing. Is XMM0 going to be set to what we expect it to be set to? Well, it's set to something. It's set to something we can't really examine very well, because it's this value. We can't even copy this. Zero A, zero A. I mean, it's presumably loading this. It's 49. Wait, did it load backwards? Oh. 0x31. Ah, so it's actually here. And 30 would be the next one, which is this 0. And it's just as you go to the left. So 31, 30, 30, 30. 0A, which is that new line. Yeah, so 0A's are the new lines. Interesting. Load DDQ XMM from array. Okay. I mean, this does work at least. Although, really, like, you have all this core SIMD stuff, but then you can't do a p-test. Okay, well, I mean, I guess push RAX and then pop RAX, like, oh god, we kinda need to save it. Push XMM0, pop XMM0. Wait, can we push XMM0? No, we can't. Well, I suppose, I mean, nothing's useful. Yeah, this is the only SIMD in here. Okay, so load DDQ into XMM0 from RAX. So that's this load aligned, pretty much. Then we have this line feed thing, and we kind of want to do a wide compare. And now you have to track it in your head. I have to track it and it's like, oh, XMM0, yeah, that thing contains the 16 bytes of the string. Yeah, that's why you wouldn't want to write inline assembly. But let's just see what that would be. Just follow this. Eq epi 8. Pcomp eq q pcomp eq b. XMM. So p comp ik b xmm, well, xmm 0, and then that lf thing, that can I just do this? Suppose the register should go here. Alright, well, there is that instruction, it's doing it. And let's see, xmm0 is now ff right here, which is what we wanted. Kind of. And it's kind of what we wanted. And now we can do it, that p-test that I was talking about. Like p-test right here will presumably work. I mean, we don't even really need this compare, then. We can just do a p-test on that. There's p-test, there's our register, and that is our 0 flag. Okay. Well, 0 flag wasn't set. Which is correct, because some of it equals. I mean, it's like, and any new line. So can I just move any new line 1? Like, is that something I can do? It is. Except this one would be like a conditional move. Something like this. Jump if equal is not, excuse me. What opcode am I supposed to be using? Jump equal. Like, it's something like this. Is that something I can do? Yeah. Test. I mean, it might be inverted there. Let's see. Okay, so any new line. is 0. So we step through that. Yeah, so it's not equal. Well, so yeah, it's jump not equal to L1. Actually, what exactly happened there? Hold on. Jump if equal to L1. Zero flag is not set. Oh, any new line is set. Yeah, because that's the next instruction anyway. But then I want to jump out of the assembly block altogether. Yeah, partial assembly is not exactly a great experience. Not that assembly in general is a great experience. But partial assembly in D is also not great. But really this is the equivalent. Well, that actually we do need that. Everything's gonna need that. What is the equivalent of that? Yeah, this is a lot more debuggable, because at least you can examine variables and don't have to look at registers so much. Why do we keep stepping into that? Okay, now we don't have any inline assembly running. So that's the characters, that's the compare result. Yeah. I mean, if there was a fast way to just detect a new line, then kind of what I want to do is like, well, if any of them is equal, right, then just set, it's like if any, right, if no new lines, then size plus equals 16. Then just jump forward by 16. Else break, essentially. That's kind of what we want to do here. And then we can just do a scalar loop right here to find that new line. And of course, it's not the only one. There's also this. There's also this one that we need to check for. So compared to that, then byte 16 any new line would be LF or CR. Really? Do I have to do it bitwise or something? I mean, I guess that works. Well, let's examine that. Okay, LF16 is what we want it to be. Share 16 is just that. Any new line? No. I mean, I'm guessing this is what we want it to be, or not. Oh wait, CR16. CR16 is what we want it to be. Okay. Well, actually, we kind of do need unprocessed. Well, we need mem, really. We need mem. So, there it is. That is our memory. LF compare. LF compare is that, CR compare is that, and any new line is just that. Which is correct. If only I was allowed to just use that as a boolean. If only. Okay. I'm gonna go take a short break. Yeah, I don't know, it is kind of strange that I can't just use it. I can't just use it as a boolean, because isn't the p-test like there? Like when you use something as a boolean, it's just a test instruction. Seal. It's just a test instruction. So presumably, can't you just generate a p-test? If you're gonna use a wide register? Must be a way to just do that. Maybe bool. No, the bool isn't. Yeah, well, hold on. That's not bool. No, bool. No. Okay, so bool does not appear here. Well, really, so this is wide. This is wide. So just need to convert this to that. And that's it. That's all I want to do. I just want to convert the wide version to a non-wide version. And really, I shouldn't have to. I should be able to just write this. And if Tcompiler wasn't dumb, it would just generate a p-test there. But we don't live in that world, I suppose. Any new line? Well, yeah, that is ouch 16. Any new line 16. That is the new line. I mean, honestly, if Tcompiler wasn't dumb, I would be able to just write if, you know, ch16. I mean, that's basically what I'm writing anyway. If ch16 equals or ch16 equals, then just break. But as it stands, I can't really do that. I mean, well, not that C intrinsics would help much either, right? Because this returns a 128. Well, actually, no, they won't help. Because this only compares the lower, yeah, this is not what we want. Yeah, this returns a one, like, this stuff as well, the 0xf, like, a wide thing, so you wouldn't be able to use that. But there is a p-test intrinsic. Yeah, there. There is a p-test intrinsic, so actually C intrinsics would help because of that. And so this is what we want really, is test, no, test, no, really? It's like, really? Built-in SIMD intrinsics. Yeah, hold on. Don't they have? Is there a list? Wait, hold on. This is the list. Like load, move, store, like add, subtract, or whatever. So this is where you would find a test for intrinsic. If there was any. But there isn't. P-test intrinsic. Well, apparently there is something called an intrinsic op. No, I specifically want a p-test. No. You just don't have it. Apparently. Like, there is no equivalent of this. I mean, there is an inline assembly. But mixing in inline assembly sort of halfway through is actually it's actually not what you want. Kind of not what you want. Well, I mean, we have this thing, right? We have this any new line 16 thing. Like with like all of this stuff is going to be in registers, right? So we can't just like randomly use a register without, yeah, but yeah, writing assembly right in the middle, unless there are unless the compiler is smart enough to like look at your inline assembly and make sure that the code it generates doesn't mess with it. Which I doubt. Man, that's so annoying. Like the compiler has a way to just do this. Like it could just do this, but it just refuses to for no reason. It's so annoying. Why want to do the thing? Yeah, so this break right here would be this jump. So if it's 0, then it jumps wherever that is. Here, presumably. (92, 76, 92). Yeah, so it jumps here. Otherwise it jumps out. Test. Jump 0 flag, jump 0. Move. EDX 10. Add, jump. Yeah. So annoyed. So upset. So upset. Like, you can keep the same code. Just change this to p-test. Pretty much. Yeah. And it's one of these. Yeah, it's that. Yeah, that's what CL is, alright. So annoying. Just... Okay, well, if there is no way to generate a p-test without inline assembly, which, by the way, this also doesn't list a p-test as an instruction it supports. I think you can still write it. So maybe this is just not a complete list. Actually, let's see. Is it open p-test? Like, no, yeah, it does support p-test. Yeah, that's fine. Well, at least it appears here in the backend code, so presumably it can output p-test just fine. It just refuses to let me do it. But then, yeah, okay, well, I guess we aren't doing it then. Let's just discard all of these changes. Can I just like select and then discard changes? Yes. Actually, can I do that selectively? No. You can discard all changes. Well, do we have any to-dos otherwise? No. We don't. That I was. Is it still working, or did I mess something up? Let's see. that works for me. Okay, I think this is all I'm gonna do for this project. So thanks everyone, see you later.